Hello and welcome everybody for this next edition of the laboratory software. You already know who this is. It's Laz, and at least the live streaming is actually working. Things might be a little bit more louder than usual, only because we do have some people over, and they're playing some Mario Party in the living room and whatnot. So if you hear crazy laughter and whatnot, there's fun times going on in the other room that I just don't want to partake in, you could say. But anyways, in this edition, we're going to be checking out Consolidation. I hate being unsure about what I'm going to say. So with Consolidation testing itself, it's to determine how much will the ground consolidate when you put a load on it. It usually involves materials that are either clays, silts, peat, anything like that, where under a load it can consolidate and or retract back depending on moisture and whatnot. Unfortunately, for the example that I have for today, I don't think I'm going to be able to fill everything out because I don't have everything I need in order to do a consolidation test. I do have something to put in readings so we can see how it goes, and a little bit of a disclosure here is, while I know how to do the test, I don't fully understand the values or what you're looking at in order to determine the consolidation. I know I can look at the graph, see how the graph should be, and and you'll be able to see how much it is settled in while applying a load to the test itself and whatnot. So a little bit more background on the test itself. So this is what is called one-dimensional consolidation testing. So that's where you pretty much have a metal ring and the sample itself is collected in what's called a Shelby tube. So then you extrude the Shelby tube because the tube itself collects a sample in the ground as is in place, so it's not as disturbed, so you can test it just as it is. That's the whole idea of it. So these tests can vary from any depth that's needed to determine what kind of load testing and whatnot. And usually if this performs poorly, the test itself, or if it consolidates way too much, then they might consider installing piles. So kind of like what I talked about a little bit in the last video. So either concrete or metal piles or helical piles or something like that they can build the structure on, so it doesn't have to worry about that adjustment in the ground. But sometimes if it consolidates and doesn't really revert back after applying a load to it, they might apply what's called a surcharge. And a surcharge itself is putting a whole bunch of weight on the ground to let the ground consolidate itself. So that usually involves bringing in large stockpiles of soil and aggregate, and they just leave it on the site for however long, so a period of time, where if it's months or a year or however much. And once when the ground settles enough to the desired point, then they're able to build on it and continue from there. The only tricky part about the only tricky engineering part that I can't really cover too much because I'm not an engineer, so I don't really want to put words in professionals' mouths and stuff. But the idea is if you do that, you'll be able to squeeze the material down enough where it shouldn't be able to expand back, which the expansion comes due to moisture itself, as well as the material type. Yeah, anyways, enough of me kind of pandering about. I don't want to make it seem like I know everything about this test, because unfortunately I don't. I just know how to do the tests and how to put in the data and have an idea on what the data should look like in the end, but really it's an engineer that's going to review it and then ultimately determine, okay, how are we going to proceed? All right. Let's... Alright, so for this we are going to have to install this software package for this. So oh, there we go. So let's see here. Choose a disk file, even though I think it was in the list. Here we go, swell and consolidation. Alright, so now since we have that in our floppy drive, let's install this bad boy. Let's see that is set up. Let's continue. Ooh, no. No, nothing else to install. Alright, perfect. So that should be good to go. Alright, we got our cons section in here. So we'll just open up our last project here and let's create a new one for this one, and let's call this B20. Let's see, our depth, we'll say 42.5 to 44.5 feet, and that should be good enough. So it should be, here we go, swell and consolidation. Alright, so I do want to say for this part here, more than likely I'm just going to be ballparking what everything's going to be. This is the data that I don't have, so this so usually, so I can tell you from our end, usually what we do at our facility for consolidation testing is we will do not a full classification testing, but something pretty close to it. So we'll usually do like two natural moisture contents just to make sure we have a good average of them. We'll do Atterberg limits. Usually when you're doing consolidation testing, it's usually on material that is plastic. So fatty clays, peats sometimes can be plastic, but it's not all that often that it can be, to be honest. It depends how fibrous it is. If your peat's very fibrous, it may not be plastic. And then that's where, if it is like peat, kind of like what we've seen with the Atterberg limits, that oven dry section, technically what you're supposed to do is you'll run your Atterberg limits as you were, then with whatever remaining sample, you'll oven dry it, which means you'll put it in a 230 degree plus or minus 9 degree Fahrenheit oven, or 110 plus or minus 5 degrees Celsius oven, dry it out completely, and then redo your liquid limit again, in order to get a better idea for that. So, you know, this part we really won't be figuring out, classifying it and whatnot. We'll do a wash as well with that, is what we typically do. And we'll also do a specific gravity of soils, which the specific gravity of soils helps dial in what the material type itself and plots it better. That's what this section is here, but it's like I said, everything here I'm kind of going to have to ballpark and spitball here, because I know if you don't have any data really filled out here, it's not really going to plot anything on the table itself. So I do have load values that from a previous test that was done, you know, well over 5 years ago, that I'm going to use so we can see how it goes, but I don't know how well it's going to look with everything else. So let's see, we have our deflection table here. And for this, we're going to set it up to inches to TSF. TSF means tons per square foot. Obviously, you have a whole bunch of different ways on how you can run the test itself. Usually for us, we do it in tons per square foot for our loads and whatnot. Our consolometer number, which that's just a general reference for which consolometer you use, which that's the device that actually applies the load to your soil sample that's in that metal ring that I talked about. So we'll just say 1 for this one. So your sample height at start test. So this is really based on your metal ring itself. So usually you'll have a pair of calipers and you'll measure the diameter and the height and get a weight of it, which that's what this section is here, and all that's based upon your metal ring itself before you apply the sample. And then when you obtain your sample, clean it up, make sure that it's level on both the top and bottom of the metal ring, then you'll weigh it again so you can get a soil weight. So usually these rings really aren't that tall for the height. So for this, I'm just going to say 0.50 inches, so about a half an inch. We're not worried about an overburden pressure at all. Values as, I'm pretty sure elapsed time. Yeah, we're going to stick with elapsed time instead of a 24-hour because technically the I do have elapsed times for what I'm going to be using as an example. It's just when it comes to weekends and stuff, we usually don't work on weekends. So if we do a test on Friday, we're not taking a reading until Monday again, or holiday or something, something like that. So usually for this, you do 24 hours worth of readings, and then you move on to the next day, which the next day you're either going to apply more load or you're going to take off loads. And all that's determined by the engineer, that what the load bearings are going to be on the material that they want tested. So let's see here. So we got initial untrimmed sample data. So for this here, this is where you're going to put in like your moisture content and your specific gravity, as well as your height, diameter, and weight of your sample itself, which usually you can just follow what the ring's going to say. So the height, we're just going to say 0.50. The diameter, let's just say it's about 2.5 inches. That's what they typically are. And the weight, because this is the weight of our sample, let's just say it's going to be 75.58 grams. So this here is just your moisture content and whatnot. Oh man, a moisture content, I don't know, let's say, we'll say 158.65, and then our dry weight is nope, can't be higher than that, 23 or 6, I don't know, I'm just typing on the keyboard, and let's say it's 49.58 for the tear weight. And let's say we're working with a clay. So a clay usually has clays are usually pretty dense, so it usually has a higher specific gravity. So for soils, usually soils is 2.65 for specific gravity. Is for soils and stuff, clays is usually like 2.70, 2.78. So for this one, I think I'm just going to do 2.79. Once again, I'm just spitballing here. And then we have our post-test sample data. So this is your post-test data is after when you get done doing all the loads and everything. And depending on how many loads you're going to do, depends on how long the test is going to be. So kind of like what I was saying before, if you do a load, so for example, and this is what we're going to be starting with as well. So I'm going to be putting in as we put in our loads and what our deflection reading is going to be. So if we started with a quarter of a TSF itself, you do that for 24 hours or more, or an engineer might tell you to hold it and then just keep taking readings every 24, however many hours. So you do that times however many times that they want to do it. Typically for us, we'll do 10 loads total for material types varying and whatnot, whether if it's clay or if it's a peat like material or highly organic. But for this example here, I'm only going to be putting in 9 loads total for this whole test. So the post test sample data, once again, this is when you're done testing and you take your device apart that's holding your sample, and then you're going to do a moisture content on it. So, however you want to do the moisture content is however you want to do it. Typically for us, we'll have we'll typically get the sample in the ring itself, and then weigh that while it's wet, and then we'll weigh it again when it's dry, and we just keep it in a tare so all the soil solids can stay together and whatnot. Oh man, this is going to be a tough one. So let's say, well, we already know the tare weight. I'm just going to use the ring weight, so 75.58. And usually from consolidation testing and whatnot, your sample will consolidate, so your sample can become a little bit smaller in height during the test itself. And also, as a little bit more background, the material itself, well, the sample itself that's in the ring that's placed in the apparatus is submerged in deionized water as well, to mimic the worst case possible situation. Like it's all really based on where water tables are, but it gives it the best possible chance. If it can absorb more water, then it'll be able to, since it's completely submerged in water. But usually you don't see that until you start what's called rebounding, and that's as you're not lowering, you're removing weights from the consolometer, because once we start removing weights, then it's able to expand, and it's only able to expand because of the water infiltrating back into the sample again. And remember, this is, well, like I've indicated before, this is for materials that are like clays and peat, so they can absorb a lot of water and hold a lot of water. This kind of test you don't do on soils and aggregates, because soils and aggregates don't really absorb water as well as clays and peat can. It can still absorb water, but it's very, very minute. So like it could be 0% to maybe like 0.5 tops, but even for 0.5, like that's if it's a very porous aggregate and or sand that can hold the water, is the other thing too. So it's very minimalistic that it would affect anything. So that's the other food for thought for this test as well. So this doesn't test soils and or aggregates. This is clays and peats is what we're testing. Okay, so anyways, now I just got to try to spitball. What the hell am I going to put in this thing? And this is why it never pays to cheat the system. It's harder to cheat the system than it is to actually do the test and get the values. and this is the proof right here. This is why I wish I thought I might have had a copy of the full worksheet packet, but I only have the consolidation readings, which is helpful because that's like the hardest thing to put in. But I wish I had this data so it will work kind of correctly, and I don't know if it will or won't. Oh man, I don't know. It's just type some numbers. There we go. Ooh, wait. Whoops. I'm messing up already. This is actually supposed to be the weight of the material. So if I'm saying, because the weight of soil solids is 101.10 grams, so this should be a little bit higher than that. So is the calculator function going to work here, or is this weird? It's weird. Of course it's weird. Hold on, I gotta get my phone. I thought I was going to pull up the calculator. It's not. So let's see here. So if we have 101.10, yeah, usually it ain't supposed to be this dense, but once again, I'm just spitballing here. So actually, let me do this. I'm trying to make this as accurate as possible. So since from here, from what I typed in, it's saying we have 21.7% moisture. So, well, actually no, because that's just the weight of water. I was thinking volume-wise. No. That ain't gonna help. Never mind. I thought I had a eureka moment, and I was thinking, okay, well, I'm just going to apply 21.7% to this to get it up to whatever, but that isn't necessarily going to be the case, because that's just weight of water, and this is actual volume, which that's what it's going to figure out. Because as you can see, it's calculating what density is going to be, and that's all based on these values here. So So let's say if I do, I'm still just spitballing. Well, actually, maybe we can just do 7501. Yeah, because the density changed there. Yeah. So this is the weight of the sample itself. Okay, yeah, we'll just do that. That seems all right. All right for government work, right? All right, cool. So we have all of our basic data. We should have all of our basic data where now it should be able to plot on the chart when we look at the report what the consolidation is going to look like. Let's see, use final weight of solids. What if I say that? I don't think that does anything. We'll just leave that unchecked for now. Okay, perfect. Ooh, this is way different than what I'm used to using. Dial divisor. What if I just say 1,000? I'm hoping it's thousandths. I don't know. I'll just say 10,000. I'll just leave it like that. All right, so now we're going to... Why is it in kilopascals? Oh, no. Because I got to set everything up. No, I need in TSF. Feet in inches, TSF, pounds per cubic foot. Okay, I hope everything else looks good here. Yeah, feet per day, yeah, that seems to be fine. Let's see, compression curve only. Well, I mean, I can mess with this stuff around at the end, but I definitely need that as TSF. Okay. Well, something happened there. I don't think it saved anything. It did not. That's great. That's fantastic. I think before we get into this, again, as I try to figure things out, yeah, I know. I'm trying to. Invalid sample height. You bastard. You're really gonna be weird like this. Invalid consolometer number. Okay. Can I close now? Whew. Time rate. Let's just say quit. Yeah, let's go to con setup here. But where's there like, because you can't exit out of anything, so is it down here? Is it down here at the bottom that I can't fucking do anything to because you, oh, you bastard. Oh boy. I don't think it's liking that. See, there's sort of something right there that I can't see, but this thing's gonna be fucking stupid. So now let me see what is going on down here. There's not, wait a minute. I think there is something going on down there. There's something down there. I wonder if that's like an okay, because I can't exit out of it, and I gotta be able to change this. So I guess oh, for fuck's sakes. Okay. Then let's do... Actually, hold on. I know, I can't exit out of nothing, and I can't click on nothing. So I don't know how... I guess I could just do this and new, okay, quit. There was something that I thought I seen before. I guess not. Insert. There we go. Crash. Thank you. Okay, yeah, something is... Oh, good lord. Okay, I guess let me... Okay, let me mess around with the graphical settings and whatnot, because I'm sure that there's something down there at the bottom that I gotta be able to do, and I won't be able to do it because I can't get to it. So... What if I apply that? Oh, good lord, that looks like a nightmare. Oh my god, that looks horrible. Alright. Okay, well, that might have to be how it's going to be. Open project, las. We're doing B20. Ooh, actually, no, I'm getting ahead of myself. Let's go to options, con setup. Aha, there it is. I knew there was something down here. Okay, so maybe I just gotta leave the resolution like this and it'll work better. I mean, no surprise, right? I mean, it's an old program. Probably can't do HD. Okay, yeah, so this definitely needs to be TSF for that to work. Changing the input stress units affect only projects created in the future. Okay, well, can I change it here? You know what I mean? TSF will only affect the existing one. That's fine. Changing your output stress and pore density. That's fine because I haven't inputted anything yet. Okay, now I see how this works. How many can you put in here since it scrolls down? Holy shit, you can put up to 150. Well, I think you could probably put more than 150 if you wanted to. Nope, never mind. It only does up to 150. That is a lot of fucking readings. Okay, there we go. That's what we're gonna need. I want to see. What's the test parameters? Okay, yeah, so let's re-enter all this fucking crap again. Oh my god, this sucks. Oh man, this really fucking sucks, because now I gotta spitball again. Oh my goodness. 2.78, 0.50, 2.50, 75.01, since I have my calculator open, 58, and 1, 68, and we'll say 75.86. There we go. Alright, so now I just have some data in here. That's fine. Actually, that kind of looks better, because usually the density is a lot lower too, so that kind of looks right, for at least for most of the samples that we test and whatnot. Okay, cool. So close. Alright, so now we have all that data and whatnot. Alright, so we're going to start with a quarter of a TSF, so 0.25. Alright, so from this point moving forward, this is just going to be a lot of typing. I will say, by the time when we get to load number 6, I'm curious to try something, so I only have this specific kind of consolidation data because I was a newbie then and I didn't really understand how to initially set my dial gauge, so I would either max out my dial gauge or it would either max out or it would consolidate so much that it wouldn't make a reading anymore, where then I had to make an adjustment. And I figured out, at least the newer versions of Geosystems, the way how that works is it's just a logical number that it's looking at. So if it changed by, like, let's say 0.1 inches of a difference, whether up or down, it just wants to logically do that. So I will say, by the time when I get to that, there will be negative values, and technically you don't get that in this test. But not only is this the only data that I have, but I'm also curious to see if the older versions are the exact same way. Not that I know that anybody's still using the older versions, but also it probably isn't recommended to use an older version because it might be missing critical reporting data that's now required for today's specifications and standards. So I do just kind of want to cover that real quick when we get to that point. So from here, I'm just going to be typing. I hope this is going to be enter friendly. Okay, it is. So 0.25, so 0.1191, 1, 0.1188, 2.25, 0.1186, 4, 0.1184, 6.25, 0.11839, 0.1182, 12.25 is 0.1181, 16 is 0.1181, 20.25 is 0.1180. Oh no. And also there's a furry convention going on. That's the other reason why that's popping up on my Telegram. I didn't go to it. Mostly because I didn't really see anything interesting in the venue. I would like to go, but if I'm just going to be standing around doing nothing. So wait a minute, what the fuck's going on here? Okay, so it has those values. Huh. shouldn't be doing that neither. I wonder if it's because it's a dial divisor. What if I do 1? Oh. Oh no. What is 10,000? What does that do? Ooh, no, that's not right. I mean, 10,000 is correct. That's... Why does it default to that? It still has the values. It's just, I don't know if that's going to mess this up in the end. Okay, at 300 minutes. Let's see, we got 1174, 480, 480 minutes. Whoop. Let's see, we got 0.1173 for a reading, and then 1440 we have 0.1071. Okay, so I mean, that kind of looks alright. It's a little bit hard to tell and whatnot. I kind of don't like how this is defaulting to that, because usually it just shows the values as they are and or it should be. So overall, from what you've been seeing is, so for the test itself, we have an elapsed time. So we'll have our starting value, and it's all based on how you set up your dial gauge, whatever it's digital or analog. You'll set up your dial gauge. For us, we use displacement in inches, and then from there you'll apply your load, which is 0.25 TSF, which when it comes to, now remember, this is tons per square foot, but understand that this is only like a 2.5 inch diameter metal ring. So this isn't actually like a quarter of a ton that's being applied to it. Well, actually it is, but it's not like a physical quarter ton. You know, like it's not that. Like it's a weighted unit itself that has been verified for that particular device, as well as sample ring that is utilized, is what determines your tons per square foot. So technically, like that 0.25 tons per square foot, like I think the weight itself might weigh maybe 200 grams. So remember, it's the volume itself. So that 200 grams for that set diameter, and I'm just spitballing for like the weight here, that is representative of 0.25 tons per square foot. So that's the thing you just got to keep in mind as I'm going to keep going through all these, because I'm going to try to input 9 of these in total. This is what makes this into a nightmare. So these are our times represented in minutes. So hey, hi. Jeez, that was a really low high. Oh, excuse me. Hi, everybody. Welcome back. Laz again, streaming again. Got the food situation figured out. Everybody's all fed and happy, getting back to their game, as we're going to be getting back into where I left off. Okay, so anyways, we got the first thing entered in. Hopefully this is going to work out just fine, the way how it's going and whatnot. It's, my only concern is that everything's outputting like this, but it's actually still saving the values as is. And it's hard to tell here where this is going, because this should be curving. Oh, wait. Initial dial. Okay, hold on. I do want that because I want the T0, and I thought it was T40. Why is it 4T0? Get it? 4T0? Oh wow, percent strain. Yeah, no, we'll worry about that in the end. Okay, so I guess let's keep this going. So let's get our next one in. How convenient, did 0.5. Kind of wasn't expecting that. So the thing is if you remember where we left off with the last one, if we go back to there real quick, our last value was 0.1071 inches on our dial gauge. So as we go to the next one, your 0 mark is always going to start off with wherever you left off last, which that's just how you would do this test in general, even if you're hand plotting this. Okay, so here we go again. Let's do the tedious task. So 0.25, 0.1031. A legal function call. What the fuck happened? An illegal function call. Oh my god. Oh my god, everybody. Well, actually, no, it kind of saves some data. It still has that. That's good. Specific gravity associated has been changed. All CV constructions will be reset. You must review each time rate curve on the screen. Oh my god. Oh man, I don't even know what to say right now. Why did it do that? I have no idea why in the living fuck that happened. Oh my god. Why did it have a problem with that? Okay, well, let's try with this again. 0.1371, 25.1191, 1. I'm wondering if I'm actually going to be able to demonstrate anything, because and I can tell you, I mean, the newest version definitely does not have any of these issues. So I can only imagine people back in the day having these kinds of troubles, which I don't understand why that would be happening. Whoops, no decimal there. So I'm beginning to wonder if I should save every time, because you know, yes, a lot of this video is going to be, well, it should be me typing things in, but if this isn't going to work, then obviously I really won't be able to show anything, because I don't, you know, I don't generally keep consol reports too, so I can't even show you a what one would look like at the end. Kind of have to count on the program for that. Can I save? I feel like it saves as it goes, but yeah, I think we usually do log time and not really the square root of time. Oh yeah, no, not setup. I got too carried away. So is it because I wasn't here for a while, or what? Okay, so oh my god. Okay. I think I'm going to put in all my times. This is what I kind of do. Sometimes, nah. It's easier just to enter as I go. It's just using the worksheet that I have. It's not that easy. I wonder if it's just because I took that long of a break. But that's weird. Why that happened? I'm wondering if I need like a better way to, because I think I'm gonna mess up these numbers here. I think I'm really gonna mess up these numbers here. like a ruler or something. Something on my end, guys. That's what I'm talking about. I mean, everything else is, well, going fine so far, but let's see. Okay, so we got 6, 9. Oop, that's not 12.25. That's still not 12.25. I wonder if it's because I just messed with the settings a little bit. I don't know. 22, 20.25, 0.1021, 25, 0.1020, 36, 10, 19, 60, 0.1017, 120. We got 0.1015, 300, 0.1011, 480, which gives us 0.10, 0.10. And instead of 1440, which, 1,440 minutes is 24 hours, this is when this was performed on a Friday and picked back up on that Monday. So we have a 4320 reading, and that's 0.1004. Okay. Is it going to behave? Okay. I'm guessing because I just messed with things up here. Maybe that's why it crashed. Man, well, I guess there was like a preset thing, and I'm not going to lie, the newer versions of Geosystems I don't think has that functionality for this preset, because usually we always have to put it in every single time. So this is actually making me wonder if I should mess with our settings at work, because I didn't know you can do an automatic thing here, and I think I've seen something where you can actually put in your times too. But since it's so enter friendly, I mean, you could do the double enter to get where you go, but I know this is kind of raising other questions. All right, I just want to double check. Okay, perfect. 0.1004. Okay, so now we got 0.25, 0.0925, 1.0191, 2.25, 0.0916. There is no decimal point. Wait a minute. Oh, Jesus Christ, of course this thing. Okay, it's just getting, wait, no it's not. 0.926. Good lord, there's like an insert function? It just overwrites it. That's weird. Okay, now our graph's beginning to plot now. This is good. So, because here's our 0.25 TSF, this is our half TSF, and now this is our 1 TSF. So now it's beginning to plot here, and then over here is our linear time as it well, our log time, whatnot. So how much does it consolidate over time is pretty much what that is. Now it's coming together. 0.0913. It kind of better because as you'll see here, this is like the most horrible part of doing consolidation testing. It's not necessarily the test itself, even though it's very long and tedious, especially if you don't have an automatic method. And fortunately, we do have I wouldn't say an automatic method, but it's automated where you can set it and forget it now, which makes it a lot easier, because otherwise, if you were doing this test, kind of your first hour, you're not moving anywhere. If you're looking at these times, because remember, this is elapsed time in minutes, so there's not a lot you can do in between parts, especially if you have to sit there and pay attention to a dial gauge that is as accurate as this. And let me re-emphasize on dial gauge, because it was a dial gauge. So fortunately, now we have a digital one, which makes it a lot easier to read, which I never really had an issue with reading the dial gauges from before as I rant here, but more so if you get anybody new that's never did this before, they always mess it up. You know, they always think it's something else, and then as you put in all your data, you get something weird. See, some weird's going on here. I gotta double check that. Something very weird is going on there. Okay, and then 1440.0879. There's our 1440. So this would be your second point. Oh no. Why does it go down that far? Ooh, actually, I think the negative thing is going to work, because now I see negative values over here. See, I think that's why I was able to crack the code. So I think this whole thing's going to work out. Damn, it dipped that far. So now the tangent lines kind of skew. I mean, that's what the value that I got, though. Okay, so we got 2 TSF. Double check our value, 0.0879. I still don't know why it's doing that, but I know if we adjust this, it's going to mess up all the numbers. So, and remember, we're inputting 9 of these. We're only on the 4th one, so keep that in mind, guys. Your 10 key is going to be your best friend. .0670, 12.25 is .0667, 16.0664, 20.25, .0662, 25.0660, 36.0656, 60, we got .0651, 126, whoop, .0645, 300, .0636, 480, whoop. Let's see, 480 at .0632, and then 1440 we have .0625. That's not bad. Didn't really draw any lines or anything. See, so now this is beginning to come together here, and this is what's going to determine our consolidation and whatnot. And it's like I said, since I don't have that much of an understanding, I can't really explain the C, the CC, the PC, and the CR in the end, because usually they're looking over like C over V and things like that. But it's like I said, as much as I would like to talk about it more, I really can't, because that part I just don't understand. The performing the tests and logging the data and seeing how the graphs and how everything should go is what I have a great understanding on. But what we will be looking at the end, and what the engineers will use to determine what kind of surcharge to put on it, if they need to put surcharge, which usually they are, because as you can see with a depth like this, 45, I did 45 to 4. Should have been 42 to 44. Good job me. So think about it. You know, regardless, about 45 feet down in the ground from the surface, you know, you have what could be considered questionable material or unsuitable material. Whoa, 3 doesn't want to show up there. I don't know what these, I'm assuming these printing things mean that this is what's going to show up on the report, which is something I guess we'll see at the end. So I wonder if there's an error on 3. Actually, that probably would be, because it kind of dipped a little bit. It kind of messed with the tangent line. But yeah. But I'm pretty sure if you're an experienced person seeing this unfold, I'm pretty sure you're seeing the mistake that's 0.0360 is happening, that I have my gauge set way too low. You know, I should have gave it a lot more space to work with, and that's what happened, unfortunately. Whoops, never mind. 2.25. I thought I 0.03064, 0.0284, 6.25, 0.02719. We got 0.0259, 12.25, 0.0249, 16.02, whoops, 241, 20.25. We got 0.0234, 25. We got 0.0228. 36, we got 0.0217, 60, we got 0.0204, 120, we got 0.0176, 300, we got 0.0158, 480, we got 0.0153, and 1440, we got 0.0130. Okay, and now this is where we're going to see a correction that's going to be performed by the next load, which technically we're going to be doing load 6. I wonder if this is going to do 6 or if it's just going to go to 8. Yeah, no, it's doing 8. Okay, this one's actually load 6. Okay, so for this load I had to readjust it again and whatnot, and then I had to use math to make corrections and whatnot in order to make it plot. Because if I used exactly what was there, it wouldn't have worked properly. Okay, so I believe this is going to work since I see negative values. Whoops, just 0.25, no zeros. Okay, oh yeah, and this is starting at 130, right? Well, 0.013. Okay, so let's see, we got 0.0021, 1. Oh, this is where things are going to get more difficult because now I got 0.0029, 2.25. We got negative 0.0057, 4. We got negative 0.0090, 6.25. We got negative 0.0130. 9, we got negative 0.0170, 12.25, we got negative 0.0208, 16, we got negative 0.0254, 20.25, we got negative 0.0274, 25, we got negative 0.0302, 36, we got negative 0.0352, 60, we got negative 0.0419, 120, we got negative 0.0508, 300, we got negative 0.0578, 480, we got negative 0.0610, and it seems like it's still kind of working. The reading does not look right. 1440, because I'm too focused on the paper. 0.0669. Because when you type as much as I do, you get pretty confident with your abilities on where your hand is at. It's still showing it. I wonder if it is going to work. Let's see. Okay, let's just go to 12. Oh, this is weird. Oh, that's kind of weird. Okay, so our highest point was 6 TSF, so technically now we're backing it down. So now we're doing 4 TSF. Okay, we double check this. We're at negative 0.0669. Bueno. Alright, so 0.25. Negative 0.0659. 1, negative 0.0653, 2.25, negative 0.0651, 4, negative 0.0650, 6.25, negative 0.0649, 9, we got negative 0.0649 again, 12.25, we got negative 0.0648, 20.25, we have negative 0.0647, 25, we have negative 0.0647. 36, we have negative 0.0647 again. 60, we have negative 0.0647. 120, we have negative 0.0646. 300, we have negative 0.0645. 480, we have negative 0.0645 again. And then we don't have a 1440, but we do have a 4320, and that we have negative 0.0645, so it didn't even move over that whole weekend span. Ooh, that is not good that it's not plotting here. That is really, really, really not good. It is plotting here. It is showing that it is going back. That's kind of weird that it's doing this then that, because usually it kind of goes into like a C shape is what we should be seeing. I mean, it still seems to be plotting correctly. Ooh, but it ain't liking that, because it's showing that it probably can't print the data on 7, which isn't really too... it's not great. Ugh. Alright, anyways, here's cycle 8. Well, load number 8, which this one we did 1 TSF, so we know our numbers right. So let's do 0.25, and we have negative 0.0586. 1, we got negative 0.0570. 2.25, we got negative 0.0563. 4, we got negative 0.0554. 6.25, we have negative 0.0544. 9, we have negative 0.0536. 12.25, we got negative 0.0530. 16, we got negative 0.0525. 20.25, we have negative 0.0521. 25, we have negative 0.0517. 36, we got negative 0.0511. 60, we got negative 0.0504. Let's see, 120, we have negative 0.0494. 300, we got negative 0.0486. 480, we have negative 0.0479. And then 1440, we got negative 0.0469. Hey, what's up? Hi? Hi or bye? No? Yeah? Jesus, can you open a door? What? Quarters? Or shotgun shells? No, I ain't doing that. Whoa, man, hey, these aren't quarters. These aren't quarters at all. They're half dollars. Whoa, I haven't seen half dollars in a long time. Holy shit. Damn. Fancy. Pizza payment. Wasn't expecting that, and those guys didn't have to. I enjoy their presence. I know it's kind of messed up for me to say that, and here I am doing a live stream and recording a video. But, I mean, I'm a weirdo. So it's doing it's doing what it should, but this is kind of flatlining, which I'm wondering if that's happening because I'm using negative values. So, and since I'm not seeing a plot here, I don't think this is doing it correctly anymore. But we're still going to finish it just as we should. So that brings up a very, very interesting note at this point. So if I were to mess up this test back in the day, we would have to start all over again. And by starting all over, that means still having the sample, which is more than likely compromised and has been processed for other testing. So I'm kind of lucky that the program is, I guess you could say, logical enough to understand that you can have a starting point, which this starting point would be 0.1371, and and where if you have a negative value or a positive value, it knows exactly where to plot here with your log time, with your log that's going to be time. But unfortunately, I don't think the older program is smart enough for that. So I wonder if that's something that they kind of did because people made mistakes and they took that kind of criticism, or if the program was just so basic that it couldn't understand that or compute that. So this is actually very interesting that I'm doing this for my own reasons, honestly. But I wouldn't have expected that. I mean, especially seeing that the other program, it worked fine. Negative 0.0438. Let's see here. But I'm wondering if this dial divisor is what's messing everything up too, because it really should be showing whatever number I'm putting in and not this 0.001 spiel. It really shouldn't be doing that. So that's already another weird thing that I'm not too sure why it's doing that. So I don't know, unless it was just something that they did back in the day. 0.0423, 6.25, negative 0.0416. 9, we have negative 0.0411. 12.25, we got negative 0.0403. 16, we got negative 0.0400. Let's see, we got 20.25. I almost put 20.50. Let's see here. Do you like how I go, that's everybody's favorite thing, right? Let's see here. So negative 0.0392. Then we got 25. And we have negative 0.0383. 36, we have negative 0.0383 again. Yep, that's correct. 60, we got negative 0.0369. 120, we got negative 0.0348. 300, we have negative 0.0327. 480, what do we got? Negative 0.0313. And 1440, we have negative 0.0301. Okay. So that's all of our data points. Actually, I shouldn't have done that. Can't figure out which reading to delete. Click on an existing reading before deleting. What do you mean? I don't know. So I think this is going to do. I think I'm going to have to preview it. Oh wait, actually, check out this preview. Yeah, no, that is that. No, nope. Nope. That is very wrong. And it could be because of the negative values. Yeah, no, it should not be flatlining like this, as well as it should be, since we started with a quarter TSF, this really should be like back to this area somewhere. So usually it's like a C almost. And yeah, no, this is no, this is not working at all. No freaking way. What about the rate curve? You can't really even see anything from here, which is kind of annoying. I'm assuming I'm probably actually going to have to go to a regular previewer, but I already know this ain't. Nah, this ain't working. So, is there? Hey, print cons from here. Oh, it's the same preview thing. Okay, huh? Interesting. So if I did, actually, I guess let's change this so I'm not a moron. Oh, that's right, because this thing sucks. Thank God technology has changed. Why does it do that? Should I just not have spaces at all then, so I can put feet? Oh man, wow, it's something. Huh, so yeah, that did not work as it should have at all. But yeah, I mean that's kind of consolidations though. Um, I guess let me just try to, yeah, cons report. Almost kind of forgot. Yeah, so I mean, kind of like what I was saying. Like this top part looks accurate. Um, I think it only fell short because everything was a negative value, so it just flatlined, which kind of makes sense that it did that. It's just, I don't know. I guess let's try some different things because this is percent strain. Everybody's is a little bit different for when it comes to that. So let me see here. Compression curve. Let's see. First load. Dial rating. Pressure at restoration. Average slope of rebound and intervals. Oh, here we go. Compression report. Okay, compression curve only. We'll do tabulate CV values, even though I don't think it's going to do that. So, overburn, swell. And also you can adjust the report title however in the world that you want. Engineering units, that's what the hell are engineering units? Are those SI? Oh yeah, I think that's SI units. Yeah, you don't want to show construction lines. So, standard form, overburden, CV. I don't think this is really going to make that much of a difference. Changing output, calculate method, reporting option, or CV graphing tabulation option affects only newly created projects. Select the setup from the cons data entry screen. Oh, of course. I forgot about that part. You'd think I would remember from earlier, but I haven't. I haven't learned nothing from this, right? Yeah, so, let's just try the cons for. There we go. Test report, and let's preview. Oh yeah, no, I gotta change that there, which I think actually I can probably do it here. So here's percent strain. do. Probably specific gravity was not selected for the sample. Oh yeah, that's right. It told me. Test parameters. Oh, it got rid of everything else that I put in here. I wonder if that is why. My specific gravity is right there. 2.78. Oh my god. This is driving me bonkers. Whoa. Okay, hello AVG. Thanks for popping up for no reason and telling me that there is no issue going on. Good lord, this makes me want to rewatch my video to see what values I put in here. Oh good lord. I don't even think I could do it. Oh my god, what the fuck happened here? Wow, that really got fucked up. Huh. Okay, tell you what guys, I'm going to take a break here real quick, and then I'm going to pick this right back up, at least for the video and whatnot. So, I'll see you guys shortly in the video. Alright, and I'm back. So, let's see if I can try to fix this. So now this is looking more and more like a nightmare, and I think it could be because it's missing these test parameters. It's indicating that I don't have a specific gravity when I have one in here. So I wonder if I should just do 7.5 just for shits and giggles. And okay, here we go again. Whoops. Oh my god, what is going on? Alright, so 0.50, 2.50. Oh man. 7103, 585. Okay, so I wonder if that's going to fix things now since we have you know, data in here. I don't know why it keeps wanting to do that. Of course, due to a sample date change, a time rate constructions have been reset. Review all your time rate curves on screen. Okay, well, this is all fucked up, I can tell you that. So six, that's when we get into the negatives. 4, which I can't really report. 8 and 9. So will you be able to do void ratio? Okay, now I could do void ratio because now it can do volume. And then, you know, we have percent deformation, but what the fuck happened here? Oh my god. I have no idea what the fuck happened here. Why is it doing this? Oh my god. Well, hey, look, now we have negative values and... Oh man, this is... I'm having a feeling that this can't handle negative values, is what I'm assuming here. So, oops, not time rate. So what if we go to that? Okay. We're just gonna see if I'm thinking these negative values is what's messing all this up. If we did the square root of time, yeah, no, this just can't. Oh wait, it only does it for, really? Only for each individual one. That's wild. Oh yeah, actually no, the regular Geosystems is, well, I say the regular one, it is the regular one. The newer versions of Geosystems is the same way. Oh man. I just oh, it's so you can select each area. Okay, yeah, now I see how that works. I guess if you don't have a mouse, that's why you have the window function. Interesting. Yeah, it got worse for some weird reason. It just got worse than before, and I don't think that there's going to be any way that I can fix this. I'm under the impression this is only happening because I have negative values, and it can't handle that because that's still scaling like that. I know. Now I'm just going through all this, and this probably isn't going to change anything. But, I mean, hell, we're going to go through at least everything. I know it was kind of working before, and now it's not. Well, I say kind of working. I want to use that extremely lightly for kind of working because, yeah, kind of working. Ugh, good lord, I don't know. It's got to be because of the negative values. That's probably why this is all fucked up. Yikes. Yeah, no, this is. Oh my goodness. I know that this would make an engineer jump out of a window if he's seen this. Here you go. Here's our final. He probably would push me out of a fucking window. Oh my god. Yeah, no, okay, so that's very interesting. So that little hack thing that I did for us doing the negative values does not clearly work for this because it can't even plot a construction or even the dial data, which that kind of has to happen. I mean, it still does plot it, but I think it needs that in order for it to work. And yeah, I'd say for the newer version, well, not even I would say. I know for a fact the newer version you could do that, or at least version 5 you could do that, and it will still plot it because it just looks at that very first point here, this, and then where if it's a positive or a negative value, it's just going to plot it here, and then it gets plot here on your compression curve. yeah, this isn't the case. So, I mean, we sort of seen what a curve should look like. Unfortunately, we didn't. I'm kind of curious though. I wonder if we were to go to the demo one. Ooh, actually, is that's weird because I thought I said open a new project and it's. Huh, okay. I guess let me just save and exit and reopen it. I'm hoping maybe the demo one. That's weird. Or if the demo one will have a. Change. The scene view will be reset. You must review the on-side screen. Oh, whoa. What the fuck is going on here with that? Ooh, yikes. What the hell? See, why does it have a problem with the specific gravity? Even here, it has the specific gravity entered in. And, yeah. I don't even know what to say. That's really weird. Path where it should be located cannot be found. Ignore. Cons cannot be saved. Okay. Okay. So this is kind of what it's supposed to look like. I mean, this is where it rebounds back again and whatnot. So, you start here with have whatever your load is, and then you load it up. So, as you can see, your percent strain, it's consolidating. So it'll consolidate to here, and then okay. So now we'll take the loads off here in TSF, and then we get up to here. So as you can see, as we take the loads off, how it's becoming not as consolidated. It's beginning to expand again, or swell, as they would say. And then after that, we'd reapply the load again to see where it's going to go. So they usually do this rebound if they want to see how much it's going to consolidate, which you do want something kind of close to this, mostly for the fact of you don't want it to go back to where it was initially at, for the fact of that it can swell back up to that size again. And you're just trying to get all the moisture out of your material that can absorb it, like your clays and your peat and whatnot. And so if a material is doing something like this isn't that bad. If you apply, I think this one they went up to 32 TSF, so 32 tons per square foot. So, and that is a lot of surcharge to apply to something. But you can. It's just it's all based on the amount of material you're going to add. It's like I said initially at the beginning. It's all based upon soil. That's all it is in the end. So, if you see something like this, then the engineer can look at this and then they can figure out, okay, so we know what's going to go on here is going to be, and usually they try to either meet and or exceed. I would say most of the time they always try to exceed what the specifications require. So, let's say for the structure that they're going to put up, it's going to be 28 tons per square foot. Like that's going to be the weight of this building. Let's say it's just a 10-story office building or something like that. And let's say the load distribution is like 28 tons per square foot. But then they run into this clay or muck or something like that, but it's so deep that it doesn't make any sense to dig it out. Or even for this example, this is giving us a depth of 7.5 to 10 feet, which isn't that deep. But if your whole either where the building pad is or your whole job site has this undesirable material, well, it's going to cost more to remove the material, bring in new good fill in order to maintain that load. Engineering is all about finding the most cost-effective way to build something or construct something. That's all engineering is at the end of the day. So, they'll usually do consolidation tests because, hey, if we can consolidate it and if we can get all the moisture pressed out, so you can almost think about it as if you have a sponge and you fill it up with water and then you just squeeze out the water. Okay, but then you release your hand. How much of that water is going to get back in as it expands back up? That's kind of what a consolidation test is, just generally speaking. It's having that material, squeezing out the moisture, or seeing how much it consolidates until it can't consolidate anymore, or until it hits whatever point that they need it at. Like for the example I gave, if they're going to build something and it's going to be 28 TSF, but they did one step further and they just did 32 TSF to go higher. With this they can figure that out. They can figure out, okay, is this material good enough by looking at this curve and whatnot in the data to see how much it's going to consolidate. So yeah, my curve wasn't going to look like this because this one has a rebound function back. It was just going to kind of look like this, but just not this part going back. But as we've seen with the last one, it was going like that, but then it just flatlined. And it's not really supposed to flatline because it's going to expand back. This thing is not liking specific gravities for some reason. I don't know why. But if we wanted, so if we wanted to, just, cool, don't care. So if we wanted to, why doesn't it let me, I don't know. This is going to search the whole freaking, oh my god, this is ridiculous. Okay. Problem was encountered while during your save file. Most likely you were out of disk space. You should take the opportunity to the file manager to clean up some disk space. It's been saved with the extension called Geosystem. What the fuck is going on here? Okay, but then it brought it here. Oh, good lord. I think this thing's being buggy as hell. Just for shits and giggles. I know I don't have a lot of disk space. Yeah, no, come on. I still have 2.91 gigs. That is a lot of disk space left over for what's going on. And then it opened it up right back up. So, but anyways, I just want to show again. So, even if we go all the way back to, as we're rebounding, hell, we'll start with 7, with load 7, so that's at 4 TSF. As we can see here, we had negative 0.669. So understand that as you're rebounding, your number is going to get bigger, which you can see here, because here we started with negative 0.669 and now we have negative 0.645. And remember, we're negative, so the smaller your negative number, that means you're getting a positive added to it. That means it's beginning to swell back from us releasing the load. So if we go to 8 to 1 TSF, we have negative 0.645, but then here we have negative 0.469. It's swelling more. And it's because now we've taken off the weight. So that's that's the whole idea of this test, is to, if we find unsuitable material, we think, we think it's the most cost-effective process, once again, is we can build on it, but let's just apply a load of surcharge, and then we'll just let it consolidate, get to that point, and then we can start construction on it. Because even once we remove the surcharge, well, hey, how fast will it swell back up? That's the whole idea of this. So with them getting all this data and whatnot, they can determine, okay, is this material just going to swell back up to its original state, or is it actually going to stay consolidated from putting a load on it? And obviously they want it to consolidate so it doesn't move anymore, so you don't have settling as well. Because the last thing you would want is if you have like a flood or something to happen, or it's close to the water table and the water table fluctuates all the time. Okay, so now you have moisture entering and leaving this type of material. What is that going to do? Usually if there's a constant exposure to moisture, well, it can expand more. Is the whole idea. So if you get it to a point where it can't expand anymore, or where you get, where the volume is a lot less, then it can't absorb as much water. I know I probably already said this like 17 million times throughout this whole video, and I just really only want to explain it because this looks so daunting on the screen. And even with me going into it, even I start off by saying, like, look, I know how to do the test, but I don't really know what I'm looking at when it comes to the data. And like, look, I'm an honest guy. I mean, an engineer has a better understanding than me. If we did these more often, I think I would be a lot better at knowing this. But unfortunately, here in Florida, we don't deal with a lot of clays. We do have a lot of muck and whatnot, but that usually kind of happens more close to the surface, where people just dig it out. Or even if it's at the surface, and like my earlier example, okay, we're going to build this 10-story office building, but it's about 28 TSF of force total. Okay, well, the 28 TSF is going to just distribute evenly across this plane, but as it gets deeper, it's it can affect it even more, because you can't see how much deflection you're getting from it. If you kind of know what I mean. It's too close to the surface. If it really bothers somebody, they're just going to remove it. If they don't want to remove it because it's too cost effective, I mean, they can put in some grout piles or something like that. But it's like I said, like, look, I'm not an engineer. I'm just indicating ways and methods on how you can reinforce your earthwork to support such big loads. Is all I'm saying. Once again, I'm not an engineer. Yes, I've been doing this for 18 years, but I am far from an engineering degree, so I can't stress that enough from this. But yeah, I think that's kind of about it, honestly, for consols. I think I covered everything that I'm capable of doing, and unfortunately, for the data that I had, it didn't turn out good. I mean, great that this thing has a demo that we can look at to see how it works and whatnot. This thing is extremely buggy as hell, and I don't know if it's extremely buggy because maybe it's not intended to run on XP. This might be more like a Windows 98 ME kind of thing, maybe 95, so it might run better on those systems too, which could be the reason why we keep getting all these pop-up errors and stuff. But this is kind of the last Windows operating system. If it needs anything DOS-based, it can kind of run it, and you don't have to worry about it. And it's modern enough that you can do things, and it's not hard to do them. That's the only reason why I've stuck with XP. I mean, I could easily get 98 installed. I do have a copy of 98, but I'm not. All right, I don't think there's anybody in the chat. Nope, nobody. Okay, so no questions to be answered or asked. That's cool. I'm fine with that. So, yeah, if you made it to this, I'm glad. Sorry for the minor interruptions or the cuts that I'm gonna have to make in the video, unfortunately. But I have fun doing this. Yeah, hopefully you guys did enjoy it as well. I do love doing this and whatnot. And yeah, I'll catch you on the next one, where maybe I won't say as often. See you guys.